The purpose of this video is to help you get ready for your quiz, and the quiz is focusing on the theorems that we've recently learned. So I'm just going to jump in real quick. What you can do is you can pause the video and do the problems and then go back and look to see how you did on the problems. I've given you a function, a closed interval. The function's continuous on that closed interval and differentiable on the inside. So to decide if Rolle's theorem applies, the only thing that we have to figure out is whether or not f of a being one endpoint, is equal to f of b, and that is the question that we want to figure out. So if you substitute -2 in place of your function, you'll output -12, and if you substitute 3 into your function, you'll output 18. So f of a is not equal to f of b, therefore Rolle's theorem does not apply. Now, if Rolle's theorem does apply, remember the outcome of Rolle's theorem basically says if all the conditions are right, then there will be somewhere inside the interval where the derivative is equal to 0. Alright, and number 2, we're using the extreme value theorem. And if you look at the word extreme value theorem, the word extreme, trying to get the blue to work here, but it doesn't want to cooperate. Alright, so we'll stick with black. The extreme value theorem guarantees that there will be a maximum and a minimum if the conditions are right and we've met all the conditions. So to apply the extreme value theorem, we first of all have to find the derivative and set it equal to 0 in order to get all of the critical numbers. The derivative of this function is 3x squared minus 2x, and if we set that equal to 0 and solve it, we're going to factor out an x, and we'll get x times 3x minus 2 equal to 0. So your critical numbers are x equal to 0, x equal to 2/3, and we will use those critical numbers again in just a few minutes. Alright, so those are our critical numbers. We're going to make our table. Remember, we're trying to determine the highest x value, or excuse me, highest y value and highest x value. So I'm going to put in my endpoints and my critical numbers, because remember, those are the candidates, endpoints and critical numbers. I substitute those into the original function, and I'll get -12 when I input 2, 0 when I input 0, -0.148 when I input 2/3, and 18 when I input 3. So the absolute minimum, I'm not going to write this up exactly, I'll say it, but I'm not going to write it the way I would want you to write it. The absolute minimum occurs at x equal to -2 and is -12. So listen to that sentence. Same thing for the absolute maximum. The absolute maximum occurs at x equal to 3 and is 18. So make sure on your quiz that you write that entire sentence. Okay, and number 3, we're going to use the first derivative test to identify increasing and decreasing intervals, and then find our local max and our local minimums if there are any. So you'll recall, when you're finding increasing and decreasing intervals, you go through the same process, part of the same process that we did above. You set the first derivative equal to 0, and you get your critical numbers. And our critical numbers from above are x equal to 0 and x equal to 2/3. Those numbers basically divide our number line into testing regions so that we can see what's happening on the original function. We're using the first derivative to get information about the original function. So we're going to put our critical numbers on our number line. There's 0 and there's 2/3. We're going to choose a value in each region to substitute into the first derivative. Now, I would suggest that you substitute this into your factored form of your derivative, because it's easier to work with and easier, because all we need is the sign. We don't actually need the answer. So when I substitute a number to the left of 0, such as -1, I'll get a negative times a negative, which is a positive, which tells me the original function is increasing on that interval. A number between 0 and 2/3 would be 1/3. So if I substitute 1/3 back into the first derivative, I'll get a positive. And when I substitute 1/3, I'll get a negative, and a positive times a negative is a negative. Therefore, the original function is decreasing. When I choose a number greater than 2/3, like 1, 7, whatever, and substitute, the output will be positive and the function increases. So you can see that the function is increasing from negative infinity to 0, and then again from 2/3 to infinity. The function is decreasing from 0 to 2/3. We have a local maximum occurs at x. Again, space-wise, I can't write the whole sentence, but you write the sentence. Local maximum occurs at x equal to 0 and is, we know the output for 0 on the original function is 0. And then you're going to write because the first derivative changes from positive to negative at that value. So you got to write the whole thing. There is a local minimum occurring at x equal to 2/3 and is, we could say, f of 2/3 for the exact value because the first derivative changes from negative to positive at that value. Okay, and then the next thing that I'd like to review for your quiz is an inverse derivative. Same function, we're finding the derivative of the inverse at negative 12. Make our chart, original, inverse. Keep in mind that this is an x value of the inverse, so I have negative 12, and then because they're inverse functions, the y value on f would be negative 12. Now remember from the other work on the other side that when we substituted negative 2 into the original, we output negative 12. So we already know that when y is negative 12 on the original function, the x value is negative 2, meaning that this is his y value is negative 2. These two guys are corresponding points on inverse functions, so we're going to find the derivative on the original function at negative 2. Once we find that, we're going to take the reciprocal and we'll have the derivative on its corresponding point. The derivative of this function, as we already know, is 3x squared minus 2x, and when we substitute negative 2 into that, we will get positive 16 for the derivative at negative 2, meaning that his corresponding point would have a derivative of 1/16. So remember, for inverse functions, you switch the x and y's on the functions, and then for the derivative, you find the derivative on f, and then take the reciprocal, and it'll give you the derivative on the inverse. And finally, just to review inverse trig, the problem in number 5 asked you to find the derivative of e to the arctangent of 3x squared at x equal to 0. The derivative of e to a power is e to that power, so I get e to the arctangent of 3x squared times the derivative of the power, and the derivative of arctangent of u would be u prime, so that would be 6x over 1 plus u squared, which is 9x to the 4th, and then you are to substitute 0. So when you substitute 0, the arctangent of 0 is 0, so you have e to the 0. When you substitute 0 into the second function, you get 0. E to the 0 is 1. 1 times 0 is 0. So this is what you need to look at in terms of a review for the quiz tomorrow.